So now let's discuss an example, handwritten digits. For an example of where this might be useful, let's look at an interesting visualization of some handwritten digits data, sorry. This data is included in Scikit-learn and consists of nearly 2000 8x8 thumbnails showing various handwritten digits. For now, let's start by downloading the digits data and visualizing several of the example images with plt.imshow. Okay, load images of the digits 0 through 5 and visualize several of them. Now from learn data sets, import digits, load digits, and as equals to 6 big ax plt dot subplots 8 by 8 big size for I makes I in enumerate ex dot flat exi dot show digits images I c map equals to binary exi dot set x ticks y ticks So now we will have a sample of handwritten digit data. Let's wait. It's loading actually. So we have this. Because each digit is defined by the hue of its 64 pixels, we can consider each digit to be a point lying in 64-dimensional space. Each dimension represents the brightness of the pixel. But visualizing relationships in such high-dimensional spaces can be extremely difficult. One way to approach this is to use a dimensionality reduction technique such as manifold learning to reduce the dimensionality of the data while maintaining the relationships of interest. Dimensionality reduction is an example of unsupervised machine learning. We will discuss later on. So now we will start another code that projects the digits into 2 dimensions using isomap. Manifold board. So map iso is equals to isomap and components is equals to 2 projection iso dot fit transform data. Now we'll use our discrete color map to view the results, setting the ticks and CLIM to improve the aesthetics of the resulting color bar. So now plot the results, plt dot scatter projection 0. Projection LW. C is equals to digits dot target cmap lt dot cm cube helix color bar text equals to range label digit value lt dot 0.5 5 point. So now manifold embedding of handwritten digit pixels we have here. So the projection also gives us some interesting insights on the relationships within the dataset. For example, the ranges of 5 and 3 nearly overlap in this projection, indicated that some handwritten 5s and 3s are difficult to distinguish and therefore more likely to be confused by an automated classification algorithm. Other values like 0 and 1 are more distantly separated and therefore much less likely to be confused. This observation agrees with our intuition because 5 and 3 looks much more similar than do 0 and 1.